students. Now in this session I am going to discuss what are the types of fluid. Okay, types of fluid. There are so many types of fluid. In the last session I have discussed what is real fluid and what is ideal fluid. Ideal fluid are those fluid which does not have any viscosity and does not have surface tension also, and does not affect the compressibility effect also. It does not have any compressibility effect. For that example, we have taken only water. Water is considered to be the ideal fluid. But in actual practice, it is an imaginary concept. If there is a fluid, definitely it has some surface tension, it must have some viscosity and compressibility effect will be there. So, most all the material, all the things available in the world are definitely have some viscosity, must have some surface tension, so they are called the real fluids. Okay. Based on that, there are so many other types of fluid also that today I am going to discuss in this session. First is Newtonian fluid. Newtonian fluids, non-Newtonian fluids, non-Newtonian fluids. Okay. Number 3, dilatant fluids. Dilatant fluids, pseudoplastic fluids. Okay. Bingham plastics, Bingham plastic fluids. Thixotropic fluids. Okay, so see types of fluid. First of all, Newtonian fluid, either is non-Newtonian fluid, then dilatant fluid, then pseudoplastic fluids, then we will discuss Bingham plastic fluids and thixotropic fluids. Okay, so let us discuss one by one. Okay, let us discuss one by one. Number 1 is Newtonian fluids. Newtonian fluids. Okay, there is Newton's law of viscosity that says that tau is directly proportional to its velocity gradient. Okay, so that equation is tau is equal to mu du by dy. Okay, this is Newton's law of viscosity. Okay, so such types of fluids which obey Newton's law of viscosity is called Newtonian fluids. Newtonian fluids. Okay, so fluids which obeys Newton's law of viscosity, tau is equal to mu du by dy. Okay, so this is called Newtonian fluids. Newtonian fluids. This is the conditions. A fluid to be Newtonian fluid, that condition is you must obey Newton's law of viscosity, which says that viscous shear stress in fluid medium is directly proportional to its velocity gradient. This is your velocity gradient. Okay, and this is shear stress. This is shear stress and this is velocity gradient. Okay, so if the shear stress is directly proportional to its velocity gradient, the proportionality constant is absolute viscosity. This equation is called Newton's law of viscosity. So Newton's fluid always obeys this law. For example, we can take like water, air, glycerin, okay, etc. These fluids obeys Newton's law of viscosity equation, and that is tau is equal to mu du by dy. So such types of fluids are called Newtonian fluid. Okay. Second is non-Newtonian fluids. Non-Newtonian fluids. Non-Newtonian fluids, a fluid which does not obey Newton's law of viscosity. Newton's law of viscosity. Which does not obey Newton's law of viscosity are known as non-Newtonian fluid. Non-Newtonian fluids. Okay. So that is condition is tau is not equal to mu into du by dy. This is the condition for non-Newtonian fluid. Okay. Non-Newtonian fluids. For example, we can take a example like slurries, gel, paste, etc. Okay. Here, see what are the another fluids are there, like dilatant fluid, pseudoplastic fluid, Bingham plastic fluid, thixotropic fluids. All are types of non-Newtonian fluids only. Okay. So based on this, let us draw one diagram. Diagram is, this is shear stress, or it is called rate of deformation, or it is nothing but du by dy. Okay. And this is tau. So tau, this is vertically, and this is x. So whenever we draw Newtonian fluid and non-Newtonian fluid diagram, Newtonian fluids figure will be like this. Okay. This is tau is equal to mu du by dy, and non-Newtonian fluids are this. So this is for Newtonian fluids, and this is for non-Newtonian fluids. So this is the graph between shear stress and shear strain. This is also called shear strain or rate of deformation. So here in this session we have defined Newtonian fluid, non-Newtonian fluid. In next class we will discuss dilatant fluids, pseudoplastic fluids, Bingham fluids, and thixotropic fluids. Okay, thank you.